Assalamualaikum and good day. How are you all? Today, I would like to present the chapter 2 on the physical principles of our subject on the BMMH 3513 component, basic component of hatchback. So, the topic will cover on physical principle. So, under chapter 2, we try to learn in deep about the unit, what unit will apply commonly used in the of component hatchback. And then the second one, conversion unit, we will study US and SI unit, the energy equation, first law, so and refrigeration, calculation of sensible latent heat change, latent heat of fusion and sublimation, ideal gas until to energy utilization, or second law of uh, thermodynamics. Yes. Okay, without delay the time, we try to go to first topic, unit conversion of units. So as we know, we have SI unit, Standard International Unit, and also British unit. So in the US unit, in the length, we have feet, an inch, and then in the volume, also sometimes we use a gallon as sometimes feet cubic, and then in the time, uh, maybe we will use same like the SI unit, the second or minute, and for mass in the British we will commonly use in the pounds, while in the SI we will implement in the kilogram, gram, and so on. Yeah? Okay, actually conversion unit is very important because engineering should be apply a lot of number in the application. If you miss something or conversion unit, you should be mean the conversion unit mean you will fail in the calculation. So if calculation fail, your design will be fail. So very careful in the conversion of unit. Okay. Okay. We have one example here how to convert the unit. Yeah. Okay. I try to uh, read the equation. Some solar heating collector panel measuring 28 in by 33 in required insulation. The insulation is to be ordered in square feet. Square feet. So in the notation, feet square. How much insulation would you order for each panel? So solution. The area of the insulation of each panel is area equal to 28 inch times to 33 inch, so equal to 924 inch square. So the area is not in the unit needed, however, the equivalent between the known and required unit is 1 feet square equal to 144 inch square. Okay, here this is arranged as a ratio multiplied by the original quantity and with unit cancel. So the area as a result from the calculation is 924 in square. So if convert to feet, it means you should be put 1 feet square equal to 144 in square. So it should be right like this: 1 feet square over to 144 in square. It means 1 feet equal to 144 inch square. So it should be converter should be put after the number of conversion. Number of conversion in front, and then followed by converter of unit. And then you can get result the conversion unit. Okay. Now we try to go to next subtopic. Yes, the energy equation, first law. The first law is referred to thermodynamics law. Yes, it means the energy cannot be created and destroyed. The change in total energy in system equal the energy added to the system minus the energy removed from the system. So energy system is mean energy come negative to energy out. So what the remain of energy inside in the system is balancing from the energy input from the energy output. So what the energy store is you can see here is energy system. Yeah? And the energy input is energy added into the system. And energy out, energy removed from the system. Okay, this one is considered to conservation energy. Refer to first law of energy, thermodynamic. Okay, energy cannot be created or destroyed. Okay, so this equation actually mostly used in the HVAC system. Yes, we try to maintain energy inside of a certain room or the space, yes, by input the supply the fresh water, fresh air or the air condition, uh, and then we try to remove the uh, the air inside of the space to the outside. So we remain the number of air inside of the room that we control. Okay. So this one example how we try to uh, reserve the energy inside of the room. Now we can check from the figure the hot water heating converter in Mr. Jones office is supply for 1,000 British thermal unit per hour of heat. It is being transferred from the room air to the outdoor at the rate of 6,500 British thermal unit per hour. What will happen in the room? What such electric heat should be Mr. Jones temporarily used to solve the emergency. So you can see if the equation from the uh, text should be implemented to be illustrate in the through the figure should be like this. Which one the Q in, which one the Q out. So the mention Jones supplying if 4,000 supply is mean input, and then order at the rate is 6,500, correct? Here, now we can make from this illustration to derive the formula. Okay, as we know, the energy of system equal to energy input negative to energy output. So as we know, energy supply is for 1,000, and while energy to release to environment is 6,500. So we can get negative 2,500 BTU, British thermal unit. Negative mean in the thermal system is mean you supply, it mean you release to the environment. Negative mean you release to environment. It mean, negative is mean you supply to the system. Sorry. Negative sign mean room is energy is decreasing. This loss in the enthalpy heat content will cause the room air temperature to drop. It mean drop, making it uncomfortable. A solution is to install on electric heater. Okay. Now we go to the capacity of an electric heater is normally expressed in watts, or W, notation in W, or kilowatt rather than BTU. So we convert the unit from the BTU to watt or kilowatt. So the conversion unit is 3,410 BTU equal to 1,000 watt. So just use this formula, 1,000 watt over to 3,410, and then you can get result in watt unit 730 watt. Refrigeration, actually, the process boiling point of a liquid depend on the surrounding pressure. As we know, from the thermodynamic theory, by low pressure you can get the higher of boiling, what we call a liquid. When we try to low pressure, you can get low of boiling point of the liquid. So lowering surrounding P, so the relationship between the temperature and pressure, I try to recall back our memory. If this one is considered as pressure, and then one we call as a T, yes. So higher T, we can get the higher pressure. So if we in the environment higher of P, so should be higher boiling of T, correct? This how refrigeration can be accomplished, So we try to convert from the liquid system to gas system, and then reverse in cycle process from the gas back into the liquid system. This one is a refrigeration process. A liquid is used that boil at a low temperature for the reduced pressure that can be achieved. Surrounding pressure is reduced below saturation pressure and the liquid suddenly boils. So what we can do to reduce the T temperature, it should be the lower of pressure. Yes, we try to treat the pressure in lower condition. Then we can get easily to process refrigeration to latent heat process. Latent heat mean it should be uh, mean the change the phase from the liquid to gas and back again gas into the liquid system. That's one we call process of refrigeration cycle. So liquid absorb heat when they boil. This heat absorbed from the surrounding at the low temperature is refrigeration. So as we know, refrigeration will release the heat to the environment, and then what happened? The refrigeration is higher temperature compared to the environment. So in that time, the environment will supply the low temperature into the system. So the system will absorb the low temperature from surrounding our environment. Okay, 2.6 calculation sensibility and latent. Okay, heat change. Uh, the process that occur in HVAC system usually involve positive or negative of heat from air or water. The calculation of heat is explained in this section. Specific heat, the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. So actually, the meaning specific heat, when you try to uh, change 1 degree of temperature, and then we try to calculate the energy for different 1 degree. How much 1 degree in 1 kilogram of liquid of mass? Then one we call specific heat. Sensibility heat change process where T of the substance change when heat is positive or negative but no change in the state of the substance. So sensibility of uh, substance measure when the absorb or release temperature or absorb the temperature in 1 degree. How sensitive? Yes, sometimes it's very sensitive, like the Hg, mercury, very sensitive. Also, refrigerant. Most of refrigerant is very sensitive into the heat change. So, how we calculate sensitivity heat equation is by Q MC delta T. Q actually we can calculate from the enthalpy or internal energy. Yes, from thermodynamic previous we can calculate Q equal to yes M delta U, or we can calculate from the M delta H. As we know, delta H is yes, delta H mean H2, negative 2, H3, H1. Sorry, we can calculate from the delta U only. Then when we try to delta H, or we can calculate the specific delta, yes. If we change from the H into the delta T, delta H into delta T should be input the specific heat inside formula for the substance. So now change from M delta H into the MC delta T. So now we know where the formula come from. Okay. Next, latent heat of fusion and sublimation. Latent heat itself, heat added or removed from the substance to change the state of substance. For example, from liquid to gas, solid to liquid, and so on. That one we call latent heat. We try to change the phase. While the heat accompanying the melting freezing process is called latent heat of fusion. Yes. Sublimation change from the gas, solid to gas at very low T and P. Sublimation is used in procedure such as freeze drying to prepare dried foods by first freezing them and then evaporate the ice in the food directly to vapor at a very low P. So we try to play with the low P. We try to get in the system aspect by low P. Why low P? Because easy to change the phase. So in the ideal gas formula, we can elaborate one formula in the calculation by relationship within temperature and pressure, where the PV equal to MRT. So P is absolute pressure, and V is volume, M is weight of gas, and R gas constant. So every refrigerant will give different gas constant. And the last parameter is T, absolute temperature. So actually, we can use this formula in calculation for ideal gas condition. When the refrigerant change into the gas, when change into the liquid phase, we cannot use anymore this formula. This equation is useful in finding change in PV or T. So the last subtopic is energy utilization. So whenever heat energy is used to do work, is never all available for useful purpose. Some lost and some unavailable for the job to be performed. Maximum amount of energy that can be made available in power producing device such as an engine or turbine can be calculated, so we can determine the best efficiency possible and compare with the actual installation. Minimum amount of energy required to produce a given amount of refrigeration can be calculated and compare with actual system. There are a number of physical effects that are called irreversible. This effect cannot be avoided but should be reduced. Yeah? The temperature difference for heat transfer, greater temperature difference cause greater loss, friction cause loss of useful energy and therefore should be minimized. Okay, so this one is the last our topic in the chapter 2. So I would like to inform you uh, for you for your attendance, I will give a question. You should be see the you learn what the question. After you answer the question, we will consider us attend the class. Thank you. That's all.